Welcome to today's video. I'm going to show you how to integrate security scanning into GitLab CI/CD pipelines. We'll start with the default scanner and then explore a couple of alternative methods. No previous experience is necessary. Let's jump right in and see what lines of code we need to write in the YML file. We'll be adding SAST scanners to GitLab. They're not a silver bullet, but they're quick and easy to integrate. Plus, they often catch outdated dependencies and prevent basic security mistakes. These are the two lines we need. We'll include a SAST template in the script and define the scan report file. Altogether, it's just 5 lines of code, but before you tune out, I should warn you. The default scanner might not find much. We'll review its results and then see how we can improve them. To test the scanners, we'll need a website with vulnerabilities. I've picked one from GitHub that's perfect for our purposes. We'll fork it there first and then import it into GitLab. HackMe is an interactive web platform designed to offer a safe and legal environment for aspiring ethical hackers to hone their skills. Sounds perfect for our needs. To get this repository, create a new fork. I've already done that, so you can see it in my projects. Now, let's head over to GitLab and import the project from GitHub. If it's your first time importing from GitHub, you'll need to log in for authorization. Once that's done, you'll see your GitHub projects and can click the import button. I've already done this, so the project is ready in GitLab. Here's a quick rundown of the vulnerabilities we might find on this website: cross-site scripting, remote file inclusion, SQL injection, and more. While a SAST scan may not catch all these vulnerabilities, it will find a good portion of them and help mitigate others by ensuring component versions are up to date. If you want to see the site locally, clone the repository and run Docker Compose in the correct folder. Just to note, I'm using a MacBook for this tutorial, but the commands and software aren't Mac specific, so you can easily replicate the steps on Windows or Linux. I've already cloned the repository, so let's just get it running. This will create a website accessible on your local host. Alright, with our test website ready, it's time to head over to the GitLab Pipeline editor. Let's grab the correct code snippets from the documentation. There we go. We'll also create a dedicated stage called Security to run all our scans. Now we need to configure the SAST job. It's defined in the template. We just need to define the scan report file as an artifact so we can view it after the scan. pipeline syntax looks good, so let's commit these changes. Since our test website is built with Node.js, the scanner template chose Semgrep SAST scanner. Here's the report. It's a JSON file listing vulnerabilities and their locations in the code. If you have a GitLab Ultimate subscription, you'd see this in a nice HTML UI, but we'll work with JSON, which is fine for us. The first vulnerability is improper neutralization of data within XPath expressions. This can lead to XPath injection, allowing an attacker to execute expressions in XML files. The developer needs to sanitize user inputs, and there's example code for doing that. The location of the vulnerability is app.js on line 144. Let's take a look in my editor to see it. We seem to have another XPath injection vulnerability, this time on line 161 of the same file. The third vulnerability is again an XPath injection. By the way, if you need more information on a vulnerability, you can copy the URL to your browser. We've reached the end of the report, and it looks like the results are less than impressive. Static scans don't catch everything. You also need dynamic scans and manual penetration testing. However, a static scan should find more than this. That's why it's a good idea to try different scanners for a more complete picture. Luckily, in today's cloud environment, this is easier than ever. I'll show you two other static scans. We'll now try setting up the same Semgrep scanner but in a different way. Instead of using the GitLab template, we'll follow Semgrep's documentation for configuration. Let's copy these 3 lines and add another scan job using this custom Semgrep configuration. I'll set the scan to output a report in Sarif format. Visual Studio Code has a nice extension for viewing these reports, which I'll show you once we have the report. While we're at it, let's also set up another popular scanner called Snyk. Both Semgrep and Snyk are excellent options and free for small teams. The provided example script is for dependency scanning, but we want a SAST scan, so let's change the command to Snyk code test. Also, we need an authentication token for Snyk, so let's get one from their website. Go to Account Settings to find the token. You'll need an account if you don't already have one. I'll copy the token into the YML, but a word of caution. This isn't best practice. It exposes the token to anyone viewing the file. I'm doing it this way to see if the scanners flag it as a security issue. I'll add the token to the Semgrep scan as well. Semgrep doesn't require it, but it provides benefits like a detailed security report on their website. There are still a couple of more fixes to do. I have to add allow failure to the Snyk scan because Snyk scan will fail if there are issues. Semgrep doesn't do that. Also, I'll make the artifacts to be saved every time, no matter what the result of the scan is. Before running the tests in GitLab, it's a good idea to test them locally. Let's install Semgrep on my machine. Now just type Semgrep login, which will open a browser and then login. I have done that already, so I can start the scan now. In reality, static scans take some time, but I'll fast forward the video a bit. The scan found 24 findings. This looks much better. Let's try the local run also with Snyk. I'll copy the installation commands from the YML file. This looks good too. There were 26 code issues. You can't compare these numbers directly though, because Semgrep and Snyk both scan a little bit differently. They may report a single vulnerability with many types of attacks when the other scanner doesn't. Now that everything is ready, let's hit the commit button. The Semgrep scan was successful, and we have the artifact. Let's check the Snyk scan results. As expected, the Snyk scan failed but provided a nice HTML report. The first vulnerability is a SQL injection, where unsanitized user input ends up in a database query, an issue the default scan missed. There are multiple instances of this in the app.js file. Next, there's a path traversal vulnerability, where unsanitized input from an HTTP parameter flows into send file, allowing an attacker to read arbitrary files. Then there's use of hard-coded credentials. This is an example website, so it's been made quick and dirty. These values were added by me during a manual install, but similar issues exist in the original version. The next one is allocation of resources without limits or throttling, which can enable denial of service attacks. That was one of the bonus vulnerabilities. Then there is a Sarif vulnerability, cross-site request forgery. This allows the attackers to execute requests on a user's behalf. The last ones are information exposure and cookies without secure attribute. As you can see, a SAST scan may find a good deal of vulnerabilities, and if you fix these, you'll be much better off in every sense. It is not perfect security testing, but when you consider the amount of work and the increased security, it is always worth it to use SAST scans. Next up, let's see the Sarif report that the Semgrep scan created. Open Visual Studio Code and install the Sarif Viewer extension by Microsoft. Click on the Sarif file to view the issues and their locations in the code. We see a Sarif issue similar to the Snyk scan, multiple SQL injections, a cross-site scripting issue, and the path traversal issue. Looks like both of these scanners find the same issues there. Then in the YML file, there is a privilege escalation issue. Snyk did not report this issue, but the reason is that Snyk has a separate scan for infrastructure files, which I didn't run. And here's an interesting issue. Snyk API key detected. So the security scanners can find secrets too, although finding secrets in CI/CD scripts is kind of a new feature in security scanners. It is a good thing to see that they do find those secrets. Then there is an issue that the Express version is outdated. When you upgrade the Express version, probably many of the vulnerabilities will disappear. A secret is hard-coded. This one we already saw in the Snyk report. That covers all the code issues found in the reports. Both Semgrep and Snyk did a fantastic job identifying vulnerabilities. Finally, I want to show you the benefit of using authorization tokens. Logging into the Snyk website gives you a detailed HTML report with more information and advice on fixing issues. Here's a similar report on the Semgrep website. That wraps up our tutorial. I showed you 3 ways to integrate SAST scanners into GitLab. Now it's your turn to do the same for your project. If you have any questions, feel free to ask. Thanks for watching.